Start by trying to answer this question on your own. The ratio of men to women at a dinner party is 4 to 5 all night. If 12 men show up to the party, how many women are at the party? We can apply known ratios in order to predict unknown values using proportion. A proportion is a statement that claims one ratio is equal to another ratio. They're an applied version of solving equivalent fractions. We've used proportions to solve missing values in equivalent fractions and to solve for percentages. In order to find missing values in equivalent fractions, we cross-multiply. So we're going to solve the same way. We're going to use cross-multiplication to solve proportions. First thing we need to do, multiply the values that are across from one another. So we have 2 times x, 2x, 6 times 5, 30. Divide both sides by the coefficient of the unknown value. X is our unknown value, so I'm going to divide both sides by 2. 2x divided by 2 gives me x. 30 divided by 2 gives me 15. That's a basic one-step equation. The shortcut that a lot of students favor is to multiply the two known values that are across from each other. Not the 2 and the x, because x is unknown, but 6 and 5. 6 times 5 is 30. I'm going to divide by the value that's across from the unknowns. In this case, 2 is across from the unknown, so 30 divided by 2 gives me 15. Let's solve the next couple problems using these methods. So if I do a true cross multiplication, I would do 2 times x to get 2x. 12 times 4 to get 48. I divide both sides by the coefficient in front of the unknown value, so the number in front of x. Divide both sides by 2. X gives me 24. If I plugged 24 in for x, I would get an equivalent fraction or equivalent ratio to 2/12. The shortcut method works great on a calculator. On a calculator, I would type in 6 times 3 to get 18, and then I would divide that by 15, by the other value or other known value. 18 divided by 15 is going to give me 1.2, so x equals 1.2. Although we would traditionally say a decimal cannot go in a fraction, in this case we're utilizing proportions and ratios to find unknown values. So in this case, 1.2 could represent anything from 1.2 miles, 1.2 hours, 1.2 cups. We're no longer just finding equivalent fractions, we're using applied ratios in order to solve for unknown values or to predict unknown values. Since there will be a lot of word problems, since ratios are very applied, we need to look at how to set up and then solve a proportion. Cross multiplication is one thing, but if we're not given a proportion to solve, we need to glean that information from the word problem itself. Every proportion has to have one ratio or one side of the proportion that has both a numerator and a denominator. We'll call this our original ratio. So we're going to set up the original ratio from the word problem. This is where understanding how to verbalize or write out a ratio helps. You're making a batch of cookies. There's a ratio of 2 cups of water for every 3 cups of flour. Well, right there it says 2 cups to 3 cups or for 3 cups. Don't get confused. It says if you want to use 5 cups of flour, how much water will you need? That 5 is compared or connected to an unknown value. That's going to be on the other side of the proportion. So we set up a ratio of 2 to 3. Since this is a word problem and our answer will represent something, in this case cups of water, cups of flour, it might help to label what our ratio represents. Our 2 cups of water is our numerator. Our 3 cups of flour is our denominator. This way I know water goes up top, flour goes down below when I set up my proportion from here on in. In order to set up a proportion from a word problem, you have to be given at least 3 pieces of information. 2 of those come from the original ratio, and the third goes on the opposite side of that equal sign. So you need to set up a proportion by filling in the third piece of given information in the right spot. Now when I say right spot, we need to look at what that third piece of information represents. Here we have 5 cups of flour. Well, in my first step, I labeled that up top my numerator is water. My denominator is flour. So in this case, my 5 cups is going to go in my denominator. The question even asks, how much water will you need? So the unknown value is cups of water. So that's why our x is up top. Once your proportion is all set up, you can solve the proportion by cross multiplying. So 2 times 5 gives me 10. Divide by 3. That's going to give me 3.33, or about 3 1/3. Always include a unit since it's a word problem. The answer is not just 3.33. The answer is not 3.33% since we know that my unknown variable there represents cups of water, so it needs to be 3.33 cups. On your own, try the problem below related to the homecoming dance.